Hello everyone, welcome in this video dedicated to UMP OX. UMP OX is a free tool, which is available both for Windows and macOS. There is also a version for Raspberry Pi which is being prepared, but it's not yet publicly available. The name UMP OX comes from UMP, which is the new standard which has been introduced a few years ago by MIDI Manufacturer Association. UMP is abbreviation of Universal MIDI Packet. So with UMP, you can deal with both with MIDI 1.0, so the classic protocol, if we can call it like this, and MIDI 2.0. UMP OX can do a lot of things. That's why I wanted to make this video to explain in detail what can be done. And this first video is dedicated to the way to start it and to configure it for the first time. There are other videos in preparation to explain more in details, more advanced function. You can find UMP OX on the GitHub website. So where you see the complete description of the software. So I will put the link in the video description. And if you want to download UMP OX, you just click on the release button here, then you get access to this page. As you can see, the UMP OX is available for macOS and for Windows. For Windows, we have made a setup system because there are some DLL to be installed along with executable file. For macOS, it's just a simple application, so you just need to unzip it and put it on the hard disk of the Mac, and it will start as a standard application. One of the key concepts that must be understood when you use UMP OX is that everything within the software is done using UMP. So it's not only MIDI 1.0, it's also MIDI 2.0. That's why we use UMP. That's where the name UMP OX comes from. UMP is Universal MIDI Packets. That's what you can find on the MIDI Manufacturer Association website. And the key object within UMP OX is called a UMP router. So what is a router? A router is a processing object which takes MIDI packets from outside world and do the processing and then send them back to the outside world. So to do that, the router use what we called sources, so they can be seen also as input ports, and the output ports are used to send the data to physical device outside. And of course, if you have a device which only supports MIDI 1.0, the router is in charge of translating incoming MIDI 1.0 data into UMP, and it's also in charge to translate UMP into MIDI 1.0 format when it goes to a MIDI 1.0 device. So, as I just told, what you find on the left side of the patch bay is what we call input ports, and what we find on the right side of the patch bay is called output ports. So the first thing that you will need before you can use UMP OX is to create routers. And we will see just after that you can create as many configurations as you want, because you can save router configuration as a configuration file. So the first thing you have to do is to go to configuration menu, then choose UMP routers. What you get here is a window showing the 16 possible routers. These are all the routers that you can find in the patch bay. So to create or to edit a router, you just need to click on a line. So let's say that, for example, we'll take the first one. When you double click on it, you get this dialog. So the first thing that you have to do is to enter a name. So the name that you use here, basically you can put whatever you want. It has nothing to see with the real device name. It's something to help you to to remember what the router is doing. So you can put any name. So on my demonstration setup, I have connected an Akai MPC Mini. So I will just call this Akai MPC Mini. Then you see here that we have different profiles. So system MIDI means the MIDI device is connected to your computer using system drivers. So typically these are USB devices. RTP MIDI and network MIDI are driverless. This is very important because you do not need any driver, any system driver to be installed in your system to use RTP MIDI and network MIDI. The communication system for RTP MIDI and network MIDI within UMPX is embedded within UMPX itself. So UMPX acts, let's say, as a driver, if we can say that. The two last one, OSC and Mbus Node, we are not going to talk about them right now. They are used for very specific application. OSC, it's as the name says, it's used for OSC protocol, and it's dedicated to be used with Open Stage Controller, which is a different piece of software. And Mbus is something that we will present in dedicated video because Mbus itself is a complete concept. So here I choose system MIDI and I will select APC MIDI. So that's the name of the device in the system, in the computer itself. So as I told you, the name that you see here, you can put whatever you want. Yeah. And I click on apply. So what I see now is that UMP OX tells me that I've created a router which is using a system MIDI profile, and you can see here that it has been able to open the device. So you see okay. If you see an error here, it means that the device is either not connected or it's not working properly, because what can happen is that it is being used currently by another software. And for example, on Windows, when you have a USB device connected to one application, a MIDI USB device connected to one application, it cannot be used by another application. I will show you very quickly because I will make a next video to give you all the details about RTP MIDI and network MIDI. So I will now enter here a configuration for a MIDI device I have here, which is a Keysbox MIDI 2TR. And on the Keysbox MIDI 2TR, we have two ports, so I will call it Keysbox MIDI 2TR port 1. And I just need to enter the IP address, sorry, I made a mistake, the address of the device, and so this is the port being used by the device, and I will put it, for example, on port 5014 locally. Apply, and same thing. What you can see here is that once I've created the router, it tries to connect to the physical device. And here, if I see connected, it means that the MIDI 2TR is physically connected. It's a network device, so not only physically connected, but it's also active, and it has answered to the connection request. So that means that UMP OX is able to exchange MIDI data with this one. And the last one I will create, it's a network MIDI 2.0. So I will use another Keysbox device called UMP2TR. And same thing, I give the IP address of my interface, and let's use this one, and 5024. I will explain you why I've changed, why I have to change this value. It will be in the coming video dedicated to RTP MIDI and network MIDI. So same thing, and it tells that this router is using a network MIDI 2.0 profile, and it's also connected to my computer. It's answering to my computer request. So basically, all the three devices now are ready to be used. So next thing, I will close this, and what we see now is that we have different icons which are now visible on the patchbay. So I will explain you what are these icons. These icons is MIDI 2.0 or UMP icon. So it means that when you see this icon here, this port is able to generate both MIDI 1.0 and MIDI 2.0. When you see the DIN icon, the DIN connector icon, like here, it means that this port is only able to generate MIDI 1.0 data. So this device does not support MIDI 2.0. The next one is, as you can see, we see again RTP MIDI. So the MIDI, sorry, the MIDI connector, the DIN MIDI connector. But we see also the network icon here. So it means that it's RTP MIDI. It uses MIDI 1.0 over RTP network, so Ethernet network. And as you can see here, we have a third icon, which is the UMP symbol, but with a network symbol. So it means that this port is able to do both MIDI 1.0 and MIDI 2.0, sorry, over the network. So we see that we have here, we will talk about this one just after. We have the UMP OX event generator, which is using UMP, and we have the free physical device. So for the free physical device connected to my computer, I have the input port and the output port. The last thing that I will do is to save this configuration. Note that when UMP OX starts, it automatically reloads the last configuration being used. So what I will do is save profile, and now I will call it my first UMP OX configuration. Sorry, my first UMP OX configuration. So you can see the name of the configuration being displayed here. And when you restart, as I said, so I will close UMP OX, and if I start it again, you see the rotor that you have created before. So once we have created a configuration or loaded it, so as I just said, you can create, save them, reload them, and you can switch from one configuration to another using the file menu. We can see now what can be done with UMP OX. And the first thing I will show you is what is called the input monitor. So the input monitor is this window. So you get access by using view, then input monitor. And what I will do, I will just use my APC Mini as tester device. So I'm now playing with different keys on my APC Mini. And if I just do anything on it, you can see the message being generated by the APC Mini. If we look to the different columns that we see, so here we have the input numbers. So we see that these data comes from router 1. So if I look in the list here, the first router that we see is the APC Mini. So if we would get data from Keybox MIDI 2TR, we would get here the value 2, and Keybox UMP 2TR will say in 3. The very important thing is that you can see that, as we told just before, everything within UMP OX is encoded using UMP, Universal MIDI Packet. So it's not like in MIDI 1.0. Within UMP, you have instruction packets which are coded using up to 4 32 bits words. And MIDI 1.0 is encoded, so it's encoded like this. So basically, you can see that let's say the old format is here. So we have B0331C, which is the MIDI. So this is the original, let's say the old format, MIDI 1.0 format, and within UMP, the thing is that the first digit here says what is the kind of data that you see just after. So a 2 here on the leftmost digit means MIDI 1.0 packet. So MIDI 1.0 packets are just made of one 32-bit packet. So that's why you see here the dash. So it says that there is no data 2, no data 3, and no data 4. And this packet use group one. So this is something which is specific to UMP, because in UMP you have the channels and you have the groups. So this message was sent from group one and channel one. And then the last thing that you can see here, it's that the message content is being decoded by UMP OX. So you see that I was generating a MIDI 10 control change. The control is 51 and value is 28, 27, etc., etc., etc. Here I have generated not on, not off. And I can see this for any devices, for any data coming except from this one. We will talk about it just after. So every MIDI data coming from the left input, from the port located on the left, will be displayed here on the input monitor. And the thing is that, of course, if we have an input monitor, we have an output monitor. So if you click on View Output Monitor, we get this different window. The thing is that output, it's not this port, to be honest. It's the same thing. We cannot display because we will see that if you use a patch with multiple connection, it would become really a mess here because you would see a lot of data being generated. So what is being displayed on UMP output monitor is what comes from a UMP aux event generator. So this one comes also from the left side of the patch. So this window tells you what data are being received from the input routers, and this one tells you what is the data being generated locally by UMP aux. And to generate some message, so that's what we will see just after, you have a lot of windows which can be opened. So for example, we can open the virtual keyboard. And now if I play anything on the keyboard, you will see that the corresponding message is being generated and you can see it in the UMP aux output monitor. So let's see right now what can be generated by UMP aux itself. So as I've just shown you, here we have the first window, which is a virtual keyboard. So it allows you to generate not on, not off. You can change the octave, you can change the velocity on, velocity off. And if you check this checkbox here, it will say that the virtual keyboard generates MIDI 2.0 message. So as I've just explained, so what you see here was MIDI 1.0 messages starting with code 2 here. And now if I play with MIDI 2.0 checked, you can see that we have a different message and it starts with code 4 this time. And it's a MIDI 2.0 not on, not off. And as you can see, MIDI 2.0 use an extended range. So when you add only 7 beats with MIDI 1.0, you have 32 bits for the data related to the not. So that's where MIDI 2.0 is really big change compared to MIDI 1.0. And you will find this in all the generator or UMPX generator. So the next one I want to show you is the program change channel. So, program change panel. And same thing, you can send program change messages. There are a lot of possibilities. So for example, right now, what I'm going to do is just say that I want to call program 21. So if I click, you see that I have a MIDI 1.0 program change for program 21. I can ask to UMPEUX to send a change bank message just before it sends. So now if I click send, you see that it sends bank change MSB and bank change LSB, followed by the program change. And the last thing is, as I show you on the keyboard, if you click on MIDI 2.0, it will generate a MIDI 2.0 message, and this is another thing where MIDI 2.0 is very different from MIDI 1.0. If I click here, you see that even if I have selected change bank, it sends a message which is program change with bank MSB and LSB. So where MIDI 1.0 was needing 3 messages, MIDI 2.0 only needs 1 message to do the same thing. The next window is control change panel. So the control change panel, oh, sorry, each time I have a second screen and the panel always open on the second window, on the second monitor. So same thing, you can here, so let's see what happens. So for example, here I will send um, since MIDI 2.0 is not checked, the slider resolution is limited to 7 bits, and I will move, and as you can see, when I move the slider, it sends MIDI control change messages. So I can change, for example, and go to this one, and now it sends not anymore to 0 but to 16. And the nice thing is when you click on MIDI to 0, then you can change the slide resolution to say 8-bit, 16-bit, or 32 bits. And for example, when I will change this, as you can see, you have a 32-bit value on the data. So it gives you access to the resolution. And as you can see, the value is pretty, compared to what could be done with MIDI 1.0, you can send really crazy value when you use MIDI 2.0. And the keyboard, we have seen it. And the last thing that you have is a custom UMP generator. So it's very useful for debugging. Basically, with this panel, you can generate whatever you want and any kind of UMP messages. So let's see, for example, what happens. So right now, by default, I generate with a message type 0, group 1, and we can change the different fields. So to know what you have to put here, you have to read what is in the UMP specification, which is available freely on MIDI Manufacturers Association website. So for example, if I send that, you see that it generates something which is new and UMP, that it did not exist in MIDI 1.0. So now, so it's NOP, it's a new operating, it says this instruction, this this command does not do anything. It's a command which is no operation. And if I go to 2, for example, then if I do that, you see that I've created something which does not exist, which is not defined in the norm. So UMP OX tells that I've generated an unknown MIDI to the 0 message. Same thing if I do that. You can see that, for example, this one is a MIDI to the 0 registered per node controller node 0. So you can generate absolutely all of the message which have been defined in the UMP specification. And the last thing I wanted to show is that when you save the profile and you close the application and you start again, you see that absolutely all the windows are being displayed again. So UMP also saves the different panel positions. And to conclude this video, we are going to take a look to the patchbay functionality of UMP OX. So right now what we have different ports here which are providing MIDI data to the patchbay, and we have output ports which are waiting data from the patchbay. And right now, simply said, nothing is happening within patchbay, because if you look, for example, for this source, so you have seen that if we use the virtual keyboard, it generates MIDI data, UMP data on this line here, but as you can see, there is no connection existing from now. So let's take a practical example. So what I have done, I have used my APC that I have declared as a router, and what I will just do, I will tell to UMP OX to connect the UMP source here to the APC Mini. So I just need to click, and when you click on intersection between a source and a destination, you see that there is a red square which appears, which shows where the connections are established. So of course you can establish as many connections as you want. You can connect as many sources as you want to one destination, so you can merge different MIDI streams. Every output port can be connected to any input port, so everything is possible. So right now, what will happen is that what I will do from the event generator within UMP OX, all the events that I will generate will go to the APC Mini. And for example, for the APC Mini, if I look to the technical documentation of the APC Mini, it says that if we go on channel 7 and we send a velocity of 3, it will light one pad with in the white color. So for example, that's what I've done. So I just played a note here, and as you can see, the APC Mini has reacted immediately. So I will play another note, and I can switch on and switch off. And if I want to change the color, let's say we will use a velocity of 7, and now it, as you can see, it goes to red. It's not very visible, but yeah, you can see it better on the camera than I see it. So these are the data given by the technical specification. So I will go to green, etc. So this concludes the video. We have seen the two basic functionality: how to create routers and how to configure them, and how to generate messages, and how to define where the message getting in the input port are being transferred to output ports. We have other videos related to more advanced functionality of UMP OX in preparation. Stay tuned, they are coming.